In this video, we will provide an overview of how to use Slurm on Hyak. Slurm is a job scheduler used to manage compute resources. It allocates, runs, and monitors jobs on compute nodes. A node is a single computer in a cluster. When you log into Hyak, you start on a login node. You can do simple tasks such as editing and creating files on login nodes. Heavier data processing and computation should be run on compute nodes using Slurm. Slurm ensures that jobs are efficient, reproducible, and can be executed without supervision. To start using Slurm on Hyak, open a command line interface and log into Hyak with the following command. You can view your accounts and partitions with the Hyak alert command. Every user is part of an account and thus has access to certain partitions. Your account is usually related to a lab or research group you belong to. For example, if you are part of the Research Computing Club, you may have an SDF account, allowing you to have priority access to SDF account resources. A partition is a group of compute nodes. The accounts you are a part of determine the priority access you have to certain partitions. Here, you can view what resources are available in each partition. This last column shows the current status of these resources. If you have a demo account, the output to Hyak alert will look something like this. Demo accounts should use the checkpoint partition. The checkpoint partition is for community idle resource usage. Users can submit jobs to run on other compute types while they are not in use via checkpoint. There are 3 checkpoint partitions that are available for anyone to use: checkpoint, checkpoint G2, and checkpoint all. Note that non-GPU checkpoint jobs will be stopped and requeued every 4 to 5 hours, while GPU checkpoint jobs will be requeued every 8 to 9 hours. Jobs can also be stopped and requeued at any time if a resource contributor requests a resource when using checkpoint. Checkpoint job limitations and availability will be displayed at the bottom of the Hyak alert output. Checkpoint limitations will only appear when checkpoint is limited in the number of jobs it can run. It will look something like this. During heavy I/O times, checkpoint jobs may be throttled. This is to optimize storage performance and prioritize general cluster navigation and contributed resources. Note that this is specifically for the checkpoint partition. Priority queues will never be throttled. While it may appear that the compute nodes are underutilized, the file system server is above 90% utilization at these moments and not idle. Now that we know about accounts and partitions, we can dive deeper into job scheduling. There are 2 ways you can run jobs on Hyak. You can either send a job to a compute node to run in the background, or you can interactively switch to a compute node. You should never run jobs directly on login nodes. Login nodes are the front doors of the cluster that everyone must pass through. We try to keep traffic low here to maintain accessibility. Because of this, heavy processes should use Slurm on compute nodes. So when should you use a batch job, and when should you use an interactive job? Batch jobs allow you to submit your command script for execution when resources become available. You do not have to worry about waiting for your job to finish or your job being interrupted by a wavering internet connection. Because of this, longer jobs should be run as batch jobs, while shorter processes such as debugging or code development should be run interactively. You can submit a job to run in the background with the sbatch command. To try out this command, you will need a command script. In the terminal, change to a working directory where you will save any tutorial files. If you are unsure where to save your files, you can utilize the scrub directory. Scrubbed is a community storage directory on Hyak. Files here will be deleted after 21 days if they are not being used. Use the makedir command followed by your UWIT ID to create a directory for yourself in Scrubbed if you have not already. Change into this directory using the cd command. Input nano myjob.slurm to open the nano text editor interface and to create your command file. All Slurm scripts will start with the hashtag and an exclamation point, followed by bin bash. This tells the system that the script should be interpreted as a bash script. Command or Slurm scripts will also contain Slurm directives. These directives define job settings and will start with sbatch. This directive defines the job name. This will be the name that will appear in the Slurm job queue. This defines the output file name, where %j will be replaced by the job ID. This directive is for the error file. Any error messages generated while the job runs will be written to this file. This directive sets the maximum time your job is allowed to run. If the job exceeds this time limit, Slurm will automatically stop it. This specifies the partition your job will run in. This directive sets how many CPU cores each task in your job can use. If you are interested in running GPU jobs, you can add an additional directive with the following format. This directive sets the amount of memory per node your job can use. This line prints a message to the terminal when your job starts. It will show the job's unique ID and the hostname of the node that is currently running the script. The date and time your job starts and finishes will also be printed to the output file. This command causes the job to sleep or pause for 30 seconds before completing. If the script completes the above commands within the time limit, it will print out a job completed message. To exit out of the nanotext editor, press Ctrl X. Press Y to save any changes you made, and enter or return to return to the terminal. Use sbatch myjob.slurm to submit the job. The job ID will appear upon submission. It is important to take note of this number as it can help the Hyak support team investigate errors with your job run if necessary. To monitor the status of your job, use squeue. squeue-u followed by a UWIT ID will show all queued and running jobs for the specified user. Watch squeue-u followed by a UWIT ID allows you to monitor the job queue in real time. It does this by continuously re-inputting the squeue command every 2 seconds. Note that your terminal will be fully taken over by the watch interface when you input this command. It may be useful to log into Hyak on a second terminal to run this command. Notice how the time changes every 2 seconds. When the job is completing, you'll notice the status of the job update from running to completing. After this, the job will be removed from the squeue output. Use Ctrl-C to stop this command. squeue-a followed by a group name can be used to monitor the traffic of jobs submitted by others in your group. Once you're done checking the queue, you might also want to manage or cancel a job. To cancel a job, use the scancel command. To try out this command, submit your command script once more with sbatch. To cancel a job, you must know the job ID. If you do not remember the ID of your job, use the squeue command. To cancel this job, use scancel followed by the job ID before the time limit. Using the squeue command once more confirms the cancellation of this job. Alternatively, you can run jobs interactively by switching to a compute node with the sload command. Similar to the sbatch directives, you can assign certain accounts and partitions with the following format. Using the sload command by itself will use default accounts and partitions. The change in the command line indicates that you have successfully started an interactive job on a compute node. You can run scripts in an interactive session with a dot and a slash followed by the script name. Note that longer jobs should be submitted with sbatch for a more stable execution. Input exit to end the interactive session. Output and error files will be created in the directory a job is submitted in. Use ls to view the contents in your working directory. Use cat followed by the output file name to print out the contents of this file. Because the job ran without errors, the error file will be empty. If you view the contents of the job we terminated early with scancel, the output should look different. The output file has no job completed message since it was terminated early. The error file will show any error messages generated by the script while it ran. To get a broader view of your jobs, including past runs and jobs from other users in your group, you can use the sacct command. It is a useful command for checking the history and details of a submitted job. You can use the Help Format option to view all output fields for this command. Lastly, you can use seff followed by your job ID to view information on resource efficiency for your completed jobs. This can help you evaluate whether you requested resources appropriately. Ready to dive deeper into Slurm? See the Slurm and Advanced Slurm tutorials on the Hyak webpage. Thank you for watching. For more information about research computing at UW, please see the video description for links to informative pages or email help@uw.edu.